This is my beginning algebra course. We're at an important part in this course because you've learned everything there is to learn. All we have to do now is review everything and take a final exam. Now, the final exam is going to be cumulative. It's not just going to cover the stuff that we covered in the last part of the course. It's going to cover everything from the entire course, and this is going to give you a chance to review and show that you know the material from the entire course. But the problem is we covered so much that it's hard to fit everything in one exam. I guess I could write a 50-question exam, but I don't want to tire you out. I've chosen to divide the final exam up into two parts. So we're going to prepare for part 1 today, and the next class you're going to take part 1 of the final exam. And here's the content of part 1. We're not going to cover everything in part 1. We're just going to cover the first half of the class or the course. So we're going to cover everything from test 1, test 2. So that's this is the first part of the class. Everything from test 1 and test 2. So it's going to cover the first half of this entire course. But I just want you to know that it's also going to cover the 3 forms of linear equations and graphing linear equations. That's from the second half of the course. I just chose to throw those things in there. So again, I want to be very clear. The test we're going to prepare for, part 1 of the final exam, is going to cover everything from the first half of the course, but also the 3 forms of linear equations and graphing linear equations. So you need to know the 3 forms. For example, slope-intercept form, standard form, and point-slope form. You need to know how to use those forms to graph equations. So I'm going to ask you to use the different methods. Remember, we learned 4 methods for graphing linear equations. So you're going to have to know those. So that's test number 1, or part 1 of the final test. So this is going to be, if you do 2 classes per week, this is going to be a 2-week process that we're about to engage in right now. Now, you can go faster if you want to. It doesn't have to take 2 weeks. You can, do this stuff faster. But anyway, now I'm going to mention the same things I mention every time I give you a test. And I'm just going to give you an overview of why, we're doing this. The reason that we're preparing for part 1 of the test is, and I know you've heard me say this over and over and over again, but I'm going to tell you again, you cannot pass a math exam without studying for the exam. That's especially true when it comes to a final exam. As math courses progress, studying for exams becomes more and more difficult. Because as you go on from test 1 to test 2 to test 3 to test 4 and finally the final exam, the amount of material that you're required to know to pass the exams just increases and increases and increases, because now we're taking a final exam where you are expected to know half of everything in the entire course. And so it takes a lot of effort and energy to prepare for these exams, and your studying intensifies. That's just the way it is in math courses, because math builds as you go through the course. And I know you don't want to hear that. You don't want to hear, well, I'm going to have to work harder and harder as we go along in this course. But again, I can't protect you from that. That's just the way that math courses work. We are now going to prepare for a test that is going to test your ability in half the entire course. So it's not enough just for you to go to one problem in one class and do that one problem and say, okay, I'm ready for the exam. No, that's ridiculous. You need to make sure you're ready to do the problems in the entire first half of this course. But the good news is you've already done these problems. So you're not going to be going back and looking at these problems for the first time. You've already seen all this stuff. So you're not going to have to spend the same amount of time learning this material. You're only going to spend maybe an eighth of the time actually learning how to do these problems. But because it's the first half of the entire course, you are going to have to look at quite a few problems, and that's why studying kind of intensifies before a test. Now, you heard me say this multiple times. I'm going to tell you again. You cannot pass a mathematics exam without studying for the exam. Doing the homework and the class problems, that'll prepare you to study for the exam. It will not prepare you for the exam. So in order to prepare, we're going to take some practice tests. Because it doesn't matter how many times you tell students to study for an exam, they will not do it. So in order to force you to at least do some studying, like in previous classes, I'm going to give you 2 practice exams to help you prepare for part 1 of the final test. And so we're going to do practice test version 1. You see over here we have version 1. This is the first practice test for part 1 of the final test. And again, these practice tests, they do 2 things. Number 1, they show you what the test is going to be like, so you can't take part 1 of the final exam and say, well, I didn't know it was going to be like that, so I wasn't ready for it. And number 2, they're going to force you to at least do some studying for the test. So if you take these practice tests, and the practice tests I'm going to give you for homework, hopefully that'll ensure that you at least pass the test. It's not going to ensure that you get an A. If you want to get an A, you have to make sure you know how to do every single type of problem, but it'll at least ensure that you pass the test. So we're going to take a practice test right now together, and you're going to do one for homework. Now, as we do this test, if you think that you can do these problems on your own, don't just watch me do them. Just like in previous classes, when we prepare for a test or we take a practice exam, I want you to do these problems on your own, if you can do them. Now, if you can't do the problem, if you don't remember how to do it, then you can watch me. But as soon as you start to remember how to do that problem, you stop that video and you do the rest on your own. Don't just watch me do the problem. You need to engage yourself in the problems, and the concepts are going to solidify in your mind much more efficiently if you actually do the problem on your own. So try number 1, and when you come back, we'll do it together. If you're not sure how to do this problem, we're trying to find y. What are the y values that make this equation work? Well, we're going to put everything on the left side of the equation. That's the first step. With these particular problems, these equations are not easy to solve. They require special methods. So that's just the typical way to solve these problems. We're going to put everything on the left side of the equation. And so I added 500y squared to both sides. And now we're going to factor out a greatest common factor, the GCF factoring. Remember, there's 6 types of factoring that we learned. So 5 goes into all these numbers, so I'm going to factor out 5. And y squared goes into all these numbers. So I'm left with y to the 4th. And that's kind of a big number. Let's see, I think that would be 101, believe it or not. I'm not going to give you really difficult numbers like that on the test, but now we have 100, it looks like. So I factored out 5y squared, and if you want to know why that works, just use the distributive property to take this and multiply back into all these terms, and you see why that works. Okay, so let's multiply back in our head and make sure that I did this correctly. You always want to check your work because it's so easy to make a mistake. So everything looks correct. So now you see we have an expression here. That's the one of the 6 types of factoring. When you have expressions of that form, it's kind of like quadratic factoring, except instead of a y and a y, you're going to have y squared and y squared because it's y to the 4th power. So now we ask, because there's no coefficient here, we can now ask what 2 numbers multiply to 100 and add up to negative 101. I know that's kind of a weird problem there, but what 2 numbers multiply to 100 and add up to negative 101? So what do you think? Again, that's not very easy. That's kind of a tricky one. But the answer is going to be negative 100 and negative 1. Isn't it true that negative 100 times negative 1 is positive 100? And isn't it true that negative 100 plus negative 1 is negative 101? Again, I know that's kind of a tricky problem. I'm not going to give you very many tricky problems like that. But anyway, so now we factored out a GCF, a greatest common factor, over here in blue. We factored this special expression here in yellow. But now, look at what we have here. Do you recognize these? We have the difference of two squares, two of them. So we have 5y squared, and I'm going to factor y squared minus 1. What number multiplied by itself is equal to 1? Well, that's just going to be 1. And then if you have a difference of two squares, it's always going to be a plus sign and a minus sign. That's just the way that those always work. So I just want to be very clear. The 5y squared, that came from there. And the y squared minus 1, that turned into these. And now y squared minus 100, that's also the difference of two squares. So that factors into a product of two binomials. And what number times itself is equal to 100? Well, that's obviously 10. And again, it's a difference of two squares, so you put a plus and a minus. So there we go. So why did we do all that stuff? I mean, what was the point of that? Well, the point is, well, now we can see the solutions that will make this equation work. So now, isn't it true that if, because the orange is multiplied into the green and it's multiplied into the yellow, all these, see the parentheses, all these are multiplied together. So isn't it true that the orange, if the orange is 0, then that'll make the equation work, because the orange 0 times everything else will make 0, you see. But it's also true that if y minus 1 is 0, that'll make everything work. That'll make the equation 0. Or if y plus 1 is equal to 0, that'll make the equation work, because again, you're multiplying. The parentheses mean multiplication. Or if y minus 10 equals 0, that'll make the equation work. Or if y plus 10 is equal to 0, that'll make the equation work. I know what you're thinking. You're thinking, why did I have to make this problem so big? Now for this one down here, you can see obviously, you know, the only value that would make that work is 0, so I'm not going to do a lot of math on that. It's not really required, you know, it's just going to be 0. So y can be 0, or solve that equation, add 1 to both sides, we see y can be 1. Or subtract 1 from both sides in that equation, we can see that y is equal to negative 1. Or add 10 to both sides, y is equal to 10. Or y would be equal to negative 10 if we solve that last equation there. Let's double check this and make sure we have all our work written correctly. Everything looks right. So we should have 0, 1, negative 1, 10, and negative 10. So those are the solutions. So as you can see, there's more than one solution to this equation. There's actually 5 solutions. And now I'm going to take this problem and I'm going to put it down here because we don't have any more room. So if you got that answer right, good job. So we had 3 types of factoring. We had the GCF factoring, greatest common factor. We had the factoring of this blue form here, which looks like a quadratic, kind of like a quadratic. And then we factored the difference of two squares. And it helped us to find 5 solutions to that equation. Believe it or not, there's 5 solutions to that equation. So let's try number 2. Number 2 is going to be much easier compared to number 1. So go ahead and try number 2. When you come back, we'll do it together. If you're not sure how to do number 2, let's get started here. We're going to factor out a GCF, just like we did in the previous problem. Negative 3 goes into negative 3 and negative 27, and I'm going to factor out 3 x factors. And so then we're left with x squared plus 9. So to see why that works, you just multiply back. Negative 3x cubed times x squared is negative 3x to the 5th power. And negative 3x cubed times 9 is negative 27x cubed. Now at this point, it's kind of a trick, because a lot of students will look at x squared plus 9 and say, hey, I can factor that. Actually, you cannot factor that. Remember, you can only factor the difference of two squares. You see these pink minus signs here? We have the difference of two squares. Down here, we have the sum of two squares. You cannot factor the sum of two squares. So what this means is we're done factoring. Now, again, we have an expression here multiplied into an expression here. So that means that if negative 3x cubed is 0, that'll make the equation work. And if x squared plus 9 is 0, that'll make the equation work. So over here we can see what the solution is going to be. I mean, we could do a lot of math on that. We could divide both sides by -3 and, you know, cube root both sides, but that's not really necessary. The only value that's going to make that equation work is 0. Over here, if we solve for x squared, because remember when you have an equation with a square, you want to solve for the square, then square root. The problem is you can't have x squared is equal to -9. That's impossible. So that doesn't produce a solution. So the only solution to that equation is x equals 0. Okay, so if you got that one right, good job. On to the next problem here. Again, if you are not sure how to do these problems, you can watch me do them, but as soon as you start to remember how to do it, don't just keep watching me do the problem. Take over and do the rest of the problem on your own. So try number 3, if you think you can attempt that. Again, you're going to put everything on one side of the equation, and they're going to factor a GCF and factor a quadratic and so on and so forth. So try number 3. When you come back, we'll do it together. All right, we're back. I'm going to put everything on the left side of the equation, and the reason I'm putting it on the left side of the equation is because we prefer the coefficient of the first term to be a positive. Could you solve it by putting everything on the right side? Yes, but it would be a lot more difficult. Remember to put your equals 0 over here. A lot of students forget to write equals 0, then the equation just disappears. So now we're going to factor out a GCF. 2b goes into everything. So to see if I did that correctly, I'm just going to multiply back. And I'm going to do that in my head, and we see everything looks right. So now we factored out a GCF, but we have a quadratic expression here, so now we're going to have to factor the quadratic. Now, when you're factoring a quadratic, obviously 2 sets of parentheses as usual, and we want to ask, is there a coefficient in front of the squared variable? And the answer is no, so that's going to be really easy to factor. We simply ask what 2 numbers multiply to -9 and add up to -8. What are 2 numbers that multiply to -9 and add up to -8? And if you said -9 and 1, you're correct. So now we changed this expression here to this expression here, and the reason we did that is because up here we could not see the solutions. We couldn't see them. But now we can see them just by looking at that equation. So isn't it true that because you're multiplying all these terms, you have this term here and this term here and this term here, you're multiplying all those and you get 0. So that means that if the yellow equals 0, then that makes the equation work. If the green is 0, then that makes the equation work. If the blue is 0, then that makes the equation work. So we want to find the b values that make the equation work. Divide both sides by 2 and we get 0. So if b is 0, that'll make the yellow 0. If b is 9, that'll make the green 0, and it'll make the equation work. If b is -1, that'll make the blue 0, and that'll make the equation work. So that's how all this, that's the logic behind all this stuff. And go back and check what we did. We want to make sure that we did everything correctly and not only got the right answer, but that we showed everything the way we're supposed to show it. And it looks right. So there you go. If you got those answers, good job. As you can see, there were 3 answers to that equation. 3 b values that you can plug in to make the equation true. So now I'm going to put a divider here. And if you got that answer, good job. Let's go on to number 4. If you can do number 4, you can attempt it. But I have to warn you, number 4 is going to require grouping. You have to factor by grouping. First, put everything on the left side of the equation. You could put it on the right, but then you'd end up with a negative on the coefficient here. You don't want that. If you can avoid it, put everything on the left side of the equation, factor by grouping, and we'll see what happens. So try number 4. When you come back, we'll do it together. If you're not sure how to do number 4, then let's go and get into it. So, like I said, put everything on the left side of the equation. Now we're going to factor by grouping. We're going to consider this to be one group and factor the GCF out of that. Then we're going to consider this other blue part here to be another group. We're going to factor a -1 out of that. And again, if you're not sure why this factoring works, you just factor back going the other direction using the distributive property. X squared times x is x cubed. X squared times 8 is 8x squared. -1 times x is -x. -1 times 8 is -8, and so on and so forth. Okay, so now we're going to factor out x plus 8 because x plus 8 is common to both those terms. We have a group here, right, that has x plus 8, but we also have a group here that has x plus 8. So that means we can factor out x plus 8 from both those terms, and we're left with whatever was, whatever's left, x squared minus 1. Now the problem is, this here is a difference of two squares. Okay, so that's we're going to need to factor that. So what two numbers multiply to 1? Or excuse me, what number times itself is equal to 1, and that's just going to be 1, obviously. And when you have the difference of two squares, you have a plus and minus, and there you go. So how did I know that's the difference of two squares? Well, because we have x squared, and we have 1, which is the same thing as 1 squared. So you're subtracting two squares. See, 1 squared and x squared, you're subtracting them. That's why we call it the difference of two squared. Subtraction means the difference. Okay, so why did we do all that? What was the point? Well, now, by putting it in this form, we changed this whole thing here to this form here. So now we can see the solutions. Up here we could not see any solutions, but down here we can see all three of the solutions just by looking at that equation. So we know that if x plus 8 is 0, then that makes the equation true, and we know that if x minus 1 is 0, that makes the equation true, and we know if x plus 1 is 0, that makes the equation true. So the big question is, what is x? What are the x values that make the equation true? Well, you just solve these equations. Solve each of these three equations individually, and there you go. So if you got that problem right, good job. There's three solutions to that equation. Okay, so on to number 5. Perform the indicated operations and simplify completely. So we have an operation here, and we're multiplying fractions. So you could just multiply straight across. Remember, when you multiply fractions, you multiply straight across, but that would be horrendous. You don't want to do that. That would be really difficult. So what we're going to do is take kind of a shortcut, an easy way. We're going to factor. We're going to factor that top expression because it kind of looks like a quadratic. Now this is multivariate factoring. You see there's an x and a y and all this stuff. So we have multivariate factoring. And something that complicates this is I have a 6 in front of the first term here. That makes things really complicated. So we first have to ask what two numbers multiply to 6. And I'm going to try 6x and x. Isn't it true that 6 times 1 is 6? So I'm going to try that. And what two numbers multiply to -6? I'm just going to try -1 and positive 6. But the difference is here you have to put y's here, you see, because we have y squared and y here. We've done this before. This is just review. So now we can't just assume that that works. And by the way, these two numbers, when you add them together, they're not going to equal -5. It might happen by accident, but they're not going to equal -5 because this term here, the coefficient of x squared, that complicates things. Remember. So now we have to FOIL. So F of foil, O of foil, I of foil, L of foil. And we know that F works because that's the way we designed it, and we know that O works, L works because that's the way that we designed it. But the question is, do these inner terms add up to negative 5xy? And obviously they don't. They add up to 35xy. So that was, we need to change things around. We need to try something different. So there's a lot of different things we can do, but I'm just going to try changing this to a 2 and this to a 3. Because isn't it true that 2 times 3 is 6? So let's try that. So F of foil, O of foil, I of foil, and L of foil. So now we know, again, we know that F is going to work, and we know that L is going to work because we designed it that way. The question is, do the inner terms add up to negative 5xy? And the answer is they don't. 12xy minus 3xy is 9xy. So that was not, that didn't work. But don't be discouraged when things don't work. We're just eliminating all the different options. You know, don't get, I mean, that's just what you have to do with these particular problems. So now I'm going to try something else. I'm going to try changing the y terms. I'm going to try changing this to 3y and this to 2y, because isn't it true that negative 3 times 2 is negative 6, you see? So now let's try FOIL again. F 2x times 3x is 6x squared. O is 4xy. I is 9xy. And L is negative 6y squared. So now if we add up the inner terms, we get negative 5xy, which is exactly what we're looking for. So we know that that's now the correct factorization. So there you go. Now I want to tell you that it probably would have been a little easier if we factored these first, because those will give us clues as to what this expression is going to be factored, because you know something's probably going to cancel out. So anyway, we factored that expression, and now we're going to factor GCF out of here. So 7 goes into both those, and x goes into both those. So I'm going to factor out 7. And again, you want to multiply back just to see if it worked. So 7x times x is, and it didn't work. I forgot a 2, you see. That's how important it is to factor and make sure you did it correctly. So 7x times 2x is 14x squared. And 7x times negative 3y is negative 21xy. So that worked. And I'm just going to rewrite the numerator here because we can't really do anything with that. And what can I factor out here? I think I'm going to try 5, and there's x's in all of them, but we want the smallest number, or the greatest power that goes into all of them. And let's see, I think 5xy is the biggest we can pull out. So then 5 times 9 is 45. X times x squared is x cubed. And then we have minus 4 y squared, so on and so forth. So again, to see why that works, you just take 5xy and multiply it into 9x squared, and you should get 45x cubed y. And as I'm looking at this, I'm double checking my work. You always have to double check to make sure this is correct. You're going to go a lot faster than I'm going right now. I'm just, I'm explaining every single step, so it's taking me longer to do this. It's not going to take you that long to do this test. Now at this point, I know you don't want to do this. You're going to get angry, but I want you to rewrite this again, just to show all the work here. And the reason that I want you to rewrite that again is that we still have something to factor. Here we have the difference of two squares. 9 is a perfect square, 4 is a perfect square, and x squared and y squared are both perfect squares, and we're subtracting them, so it's the difference of two squares. Difference means subtraction. So when you have the difference of two squares, you have to write two sets of parentheses, and remember, it's what number times itself is equal to 9? Well, that's 3. What number times itself is equal to 4? Well, that's 2. I need a little more room here. So we put our 2's, but it has to be 2y, because this is multivariate factoring. And remember, with difference two squares, you have a plus and a minus. So there's a lot going on here. Remember, this is this is a cumulative exam, so you're using a lot of stuff that you learned in the first half of this course. So now the hard part is over. We're ready to factor. And again, you want to keep going back and forth and make sure everything is written properly. It's so easy to make a mistake. Now I see 3x plus 2y on the top, and I see 3x plus 2y on the bottom. So I'm going to cancel those out. I also see 3x minus 2y on the bottom and the top. Actually, no, those are not the same. You got to be careful. Those are not the same. But I do see 2x minus 3y on the top here and 2x minus 3y on the bottom there, so that's good. So the yellows and the greens, they cancel out. So at this point, what we want to do is, we could still cross cancel, but I'm just going to multiply straight across at this point. So there's nothing really up on the top other than 7x squared y to the fifth. But the bottom we have 7x times 5xy. 7 times 5 is 35. You know what? I'm going to go ahead and cancel out that 7. We have 7 on the top and 7 on the bottom. That cancels out. So we might as well just get rid of that. So we're left with x squared y to the fifth. And on the bottom we have x times 5xy, which is 5x squared y, and we're left with 3x minus 2y. So I want to make some more room here. Okay, and now we're almost ready to write the final answer here. You see these x squareds, they cancel out, and we have y to the fifth over y, so the bottom y is going to cancel out one of the y's on the top. So you're going to be left with y to the fourth over 5 times 3x minus 2y. Now, very important to understand that you could distribute the 5 inside here and make it 15xy minus 10y, but I'm not going to require you to do that. That's just kind of a waste of time. You don't need to do that. So that's the final answer. So if you got that answer, good job. On to number 6. Now we're going to subtract fractions. And now remember, we cannot add or subtract fractions without a common denominator. And we don't just want any denominator. We want the simplest denominator we can find. But it's hard to find that unless we factor completely. So we see in the denominator at the right that we can factor out a b. And now we see we have 3 species, if you will. We have a 5b plus 1, and we have a b that's common to both of them, and then we have a 2. So we have 3 things that we need on all the denominators. So I'm going to multiply both sides of the left fraction by 5b plus 1, because we need a 5b plus 1 on the left fraction. And we're missing a 2 on the denominator in the right fraction, so I'm going to multiply both sides of the fraction at the right by 2. And you see, the reason that we did that is now we have yellow 5b plus 1s on both the denominators, and we have b's on both the denominators, and we have 2's on both the denominators, so we have now a common denominator. Just remember, if you multiply the bottom, you have to multiply the top, you see. So, again, you want to go back and check, make sure everything looks right before we proceed. It's a waste of time to proceed unless you check and make sure everything's right. So 1 times 5b plus 1, well, obviously that's just 5b plus 1. It doesn't change anything. Then we're just going to rewrite the denominators. We're going to have to use distribution here. 2 times 8b is 16b. 2 times negative 3 is negative 6. And so now we have a common denominator, and we can combine these. Now, here's the part that you really have to be careful. Okay, we're subtracting this entire fraction, right? You see this subtraction symbol here in green. We're subtracting this orange fraction. So that means that all of these signs are going to change. If you're going to make a mistake, that's probably where it's going to happen. So this is going to be 5b plus 1, not plus 16b. See, this is a positive 16b, but it's going to become negative 16b because you're subtracting the fraction. This is a negative 6, but it's going to become positive 6. Again, if you're going to make a mistake, it's probably going to be there with those signs. All right, so again, go back and constantly recheck, recheck, recheck. So now 5b minus 16b is negative 11b. Just adding like terms, and 1 plus 6 is 7. And we just rewrite the denominator, and we are done. So if you got that one right, good job. On to the next problem here. Again, if you start to understand how to do these as I'm going through them, don't just watch me do the problem. Do it on your own. Now, in this case, this is going to be pretty simple because we have completely different species, if you will. We have a yellow and a blue, but there's nothing that's the same about those. So we have no choice but to just simply multiply each fraction by the other denominator. So I'm going to multiply both sides of this fraction by x minus 3. And now I'm going to use different colors. Hopefully that'll maybe help things. Now it's very important to understand I have to put orange parentheses here, or else that's not, a correct statement. And I'm going to multiply both sides of this other fraction. Again, I must put orange parentheses. Obviously, they don't have to be orange, but I'm going to multiply both sides of that equation by x plus 7. And why am I doing this? Well, because now you see these denominators, they're the same. So again, go back and double check everything, make sure everything's right. Students have a tendency to just want to plow through this stuff, but when you do that and you don't double check your work, then it's pretty much a guarantee you're going to make a mistake. Now we're going to use distribution over here. 2 times x is 2x. 2 times 7 is 14. Again, that's the distributed property or distributive rule. Distribution property, whatever you want to call it. And over here, now this is the part where students are going to get angry. Don't get angry when I tell you this. You're going to have to use FOIL on the yellow part. Don't get angry. Just do it in your head. 2x times x is 2x squared. And I want you to add the inner terms in your head. We don't want to have to rewrite this whole thing just so you can add those inner terms. So O of FOIL is negative 6x, and I of FOIL is negative 5x. Do you agree with that? 2x times negative 3 is negative 6x. Negative 5 times x is negative 5x. So negative 6x plus negative 5x is negative 11x. That's going to make it to where we can jump through this much quicker without having to rewrite a bunch of stuff. Negative 5 times negative 3 is positive 15. So we did F, O, I, and L of FOIL. We just added the O and the I terms together. so we don't have to rewrite all this stuff. Now, I know that seems very intimidating to have to do that in your head, but it's really not that difficult at all. All you're doing is just adding two terms in your head. You already wrote the F term, so you don't have to worry about that, but you just have to calculate the O and I term and add them in your head. It's not as difficult as you might think. Okay, so now, again, if you're going to make a mistake, it's going to be right here. All right? So you need to understand that this negative is going to change all the signs in this blue numerator. So that's the type of thing that students have trouble with. So I'm going to go ahead and bring up that negative and change all those signs. So you see exactly what's happening here. And I guess I'll go ahead and just combine. Well, maybe I'll write one more step. You don't have to show every single one of these steps, but I just want to, make it clear what's going on here. So all I did with the fraction at the left was I just I just took that negative and I brought it up, so all those signs changed, you see. So I'm demonstrating that. Okay, now we have a common denominator. We're ready to add those up. So we have negative 2x squared. Remember, you can only add like terms. 11x plus 2x is 13x. Negative 15 plus 14 is negative 1. And there you go. So that's the final answer for number 7. So if you got that answer, good job. Now, as we go through this test, you might say, well, this is going kind of slow. This test is going to take forever. Well, I'm explaining every step. You don't have to explain anything when you do the test. So just be aware of that. You're going to go a lot faster. Okay, so now we're dividing a fraction, or two fractions we're dividing. So the first step is, remember, when you divide fractions, you want to change to multiplication and flip the divisor. So I'm going to flip that, and you have the following. Now we can start factoring. So I'm going to factor a GCF on the top left. So we have 2x cubed is the GCF, and we're left with x squared plus 12x plus 32. And whenever you factor out a GCF, you want to multiply back to make sure you did it correctly. And it looks right. We also have the difference of two squares. So this yellow turned into this, but now the blue is going to turn into x minus 8 and x plus 8. What two numbers multiply to 64? Or, excuse me, what number multiplied by itself equals 64? That's 8 times 8. So the blue turned into that. And I have to be careful not to write so big here. I have a tendency to make my numbers bigger and bigger. We don't want to run out of room. So I'm also going to factor a GCF out of here. And my instincts are telling me that I'm going to want to factor a negative out too. So I'm going to factor negative 10. So then we end up with negative 8 and plus x. So now we're ready to cancel. So do we see anything that we can cancel? And I'm going to get rid of the highlighting so we can do some canceling now. Well, actually, first of all, I just realized we have to factor that quadratic. So I'm going to keep going here. I know you don't want to have to rewrite all this stuff, but just do it. You want to show all your work. So what two numbers multiply to 32 and add up to 12? What are two numbers that multiply to 32 and add up to 12? The answer is 4 and 8. Okay, now we can start canceling things out. So we have an x plus 8 on the top, we have an x plus 8 in the bottom. And what else do we have? We have an x minus 8. And is this green negative 8 plus 8, negative 8 plus x, is that the same as x minus 8? What do you think? Well, yes, it's exactly the same. The only difference is the terms are just flipped around. So what else can we cancel out? Doesn't look like there's much of anything else. We have x terms that we can cancel out. I'm going to go ahead and combine everything. So 2 times negative 10 is negative 20. And the x cubed just remains there. And, whoops, I forgot my x plus 4. And what else do we have? That's about it in the numerator. And then negative 9x squared in the denominator. Now again, there are some things that I can still cancel out here. You see those x factors. We have x squared or x cubed over x squared. So these two x's are going to cancel out 2 x's on the top, and you're just going to be left with 1x on the top. So I have 1x on the top. Also, the negatives are going to cancel out. Negative divided by a negative is just a positive. And we're left with x plus 4 here. And there you go. That's it. So to make it nice and neat, you might want to move that 9 over to the middle. And there we go. Now you can distribute. You can take this 20x and put it in here to get 20x squared plus 80x, but you don't really have to do that. If you do that, then you're going to still get the right answer. It's just going to be a different form. Okay, so if you got that one right, good job. On to number 9. So now we're going to do some problems that are much easier here. It says simplify the following polynomial. So I'm going to simplify this polynomial down here. We have to just add like terms. So I'm going to start with the x squared terms because the part B says to write in descending order of power. So I'm going to just go ahead and do that all in one step. So part A, let's see, negative x squared plus 10x squared is 9x squared. So I got rid of these. I got rid of my lemons. Then we're going to do the apples next, negative 6x and 4x. Those are like terms. So we add those together, we get negative 2x. And then we have oranges that we can add up. So 18 plus 2 is 20, and it's that simple. So that was really, really easy. So that's both A and B. So maybe I should write A and B for that one, because we did two things. We wrote in descending order of powers, and we simplified the expression. So again, you always want to go back and double check, make sure you did everything correctly. Everything looks right, so now we're on to part C. Part C says state the polynomial's degree. So the degree is just the highest power of this polynomial, and you see this purple power there, that's the highest power, so the power is going to be 2. So D is equal to 2. That's the degree. And so now we're on to part D of this problem. Part D is to expand that expression. This is not related to the polynomial we just did. So a lot of students, they'll get stuck on this, or they'll say, here's the most common mistake that students make. They say, oh, this is 25y squared minus 16, or plus 16. So you see what they did? They squared this, and they squared this, and they just added them together. And they say, see, that's it. That's the answer. That's not the answer. Again, it's one of the most common mistakes. A plus B squared is not A squared plus B squared. That is not correct. All right, that's only part of the answer. Okay, now you have to ask yourself, what does it mean to square something? Well, squaring just means you're taking something and multiplying it by itself, right? So now you can probably see where the mistake happened. We have to use FOIL. Now again, don't get angry. Sometimes you have to use FOIL, so just use it. Don't complain. 5y times 5y is 25y squared. 5y times negative 4 is negative 20y. Negative 4 times 5y is negative 20y again. And negative 4 times negative 4 is positive 16. So we have 25y squared minus 40y plus 16. If you just get it done fast, then it's not going to seem so bad. Okay, so on to number 10. We're taking a polynomial and dividing by a yellow monomial, you see. So all you do is just take each term and divide. So 18 divided by 2 is 9. And I guess we have enough room to do it over here. So we have 9, and then x to the 8th power divided by x. That x on the bottom just cancels out one of the x's in the top, so you're left with 7 x's. Negative 20 divided by 2 is negative 10. And again, this x just cancels out one of those 5 x's, and we're left with 4. 2 divided by 2 is 1, so we don't have to write any 1. And the x on the bottom cancels out one of the x's, so you're just left with 1x. You had 2 and you're left with 1. So that's it. That's a pretty easy problem. Those are the types of problems where you really have no excuse for getting those ones correct, because that was an easy problem. Okay, now sometimes you have to multiply a binomial times a trinomial. And so we're going to go ahead and do that. We're going to start with, remember, you take each term in this binomial and you multiply it by each term in the trinomial. So we're going to take x and multiply it by all this stuff. So x times x squared is x cubed, right? X times 6x is 6x squared. And x times negative 2 is negative 2x. So we stayed on this yellow x the entire time. Now we're going to go to the 2. Multiply the 2 by everything inside here. So 2 times x squared is 2x squared. 2 times 6x is 12x. You can see we really don't have a lot of room there. So instead of using an equal sign and going to the right, I'm just going to go down. And then we have 2 times negative 2, which is negative 4. All right, so when we multiplied the x, we got all these 3 terms. When we multiplied the 2, we got all these 3 terms. So that's just how this works. So now we have x cubed, and add the 6x squared and the 2x squared to get 8x squared, because those are like terms. And the negative 2x and the 12x, those are like terms. Add those together, and then we have a negative 4, and we're done. So if you got that one right, good job. Again, if you start to understand how to do this as I'm explaining it, then take over. Don't just watch me do the entire thing. All right, now we're going to add 2 polynomials, and be aware that you don't have to write parentheses here when you add 2 polynomials. The only purpose of writing the parentheses is to show you that we're adding one polynomial with another polynomial. All right? So what we can do is we can just get rid of those parentheses. We're going to have to write parentheses on the negative, though, because you can't have a plus sign next to a negative. And what you can do is you can just say, well, you can just change that plus to a minus and say minus 5x squared, which is what I'm going to do. So again, when you're adding polynomials, you can just get rid of the parentheses. Okay, so now we just add like terms. We have an x cubed term. We have 2x squared terms that add up to negative 6x squared. We have 2x terms, which add up to 6x, and negative 1 plus negative 10 is negative 11. And there you go. All right, so now we're going to subtract polynomials. Now this is a little bit more tricky. Again, if you can do this problem, attempt it on your own. Go ahead and try this problem. When you come back, we'll do it together. But if you forgot how to do this type of problem, again, you can get rid of the parentheses. Now, you're subtracting this entire polynomial, is that right? Isn't that true? You're subtracting the entire thing. So what that means is that every sign in here has to change. That's a positive 4x squared, so it has to change to a negative 4x squared. All right? That's a positive 2x, so it has to change to a negative 2x. That's a negative 9, so it has to change to a positive 9. And there you go. So now we're ready to just add like terms. So it's good to write in descending order of powers. You don't have to in these problems because it doesn't tell you to, but it's good to write the x squared term first. X plus negative 2x, or x minus 2x, however you want to say it, is negative x. And 2 plus 9 is 11. So there you go. We subtracted those polynomials. So that was number 12. On to number 13. Now we're going to combine these fractions. And as I mentioned, you cannot add or subtract fractions without getting a common denominator. So we have to find a common denominator, and we don't just want any denominator. We want the simplest expression we can come up with. But we can't find that expression unless we factor. To find the simplest expression, we need to factor the denominators if they're not already completely factored. So I see I can pull out a 6 on this one. And now I have this huge expression here. I have 4 terms. You know what that tells me when I have 4 terms? That tells me it's probably going to be factoring by grouping. So I'm going to take this group here, and I'm going to factor that to 6x squared times x minus 1. And I'm going to take this blue group here and factor out a 5. So again, that was the green here, and the blue was here. I'm just going to rewrite these. And now, you see how there's an x plus 1 that's common to both the green and the blue? So that means I can pull out that x minus 1. I can do a GCF, factor out the greatest common factor, which is x minus 1. And you're left with 6x squared plus 5. That's what's left after you pull the x minus 1 out of both those terms. But now you can see why it made it so much easier to factor this, because now you see we have all these species. So I have a 6x squared plus 5 here and a 6x squared plus 5 here. And I have an x minus 1 here and an x minus 1 here. That's 2 species. And then I have an orange 6 here. So what we need to combine these fractions is a yellow, an orange, and a purple in all of the denominators. You see? So what that means is I'm going to have to take this fraction at the far left. It only has a purple. So I'm going to have to take that, and you gotta write parentheses when you multiply. And I'm going to multiply both sides by 6 times x minus 1, because it needs an orange and a yellow. And this other fraction has an orange and a yellow, so I'm going to rewrite that orange and yellow, but it doesn't have a purple. So I'm going to multiply both sides by the purple 6x squared plus 5. So just double checking everything. And now, whoops, I forgot to write my minus here. Sorry about that. Now the last fraction, I've got pretty much everything I need. I've got a yellow and a purple, but I don't have an orange 6. I'm going to multiply both sides by that orange 6. And trying to figure out what color I should use. I guess orange probably would be the best, obviously. So multiplying both sides by that orange 6. And I think that's about it. Okay, so now we have to simplify. And you see this over here? That's a big no-no. That looks like 56. It's not 56, so you got to put a dot there. Or if you want to, you can write parentheses like this. Either way, you got to do something or else it looks like a 56. So be careful of stuff like that. The way that I wrote it was incorrect. So maybe I'll do the easy part first. I'm going to do this stuff here. 6 times 4x is 24x. 6 times negative 8 is negative 48. I use the distributive property there. And I have 6 times x minus 1 times 6x squared plus 5. Now I'm going to use distribution here. Negative 7 times 6x squared is negative 42x squared. Negative 42x squared. Negative 7 times 5 is negative 35. Then just rewrite my denominator. So you can see we're doing well because we have the same denominator. You see? And now this is the part where I'm struggling a little bit to see what should I do all this in one step? Do you think we should do this in one step, or should we do this? I mean, the problem is if I multiply these together to get 30, then I use distribution in one step, then we won't have to rewrite all this stuff. But if I multiply to get 30 and then do distribution, we're going to have to rewrite every single thing here. Again, we don't have enough space. So I'm just going to put that together. 5 times 6 is 30, and then 30 times x minus 1 is 30x minus 30. So hopefully you understand what I did there. Then we have 6x squared plus 5 times, I can just put the 6 over here and the x minus 1. You know what, I want to write it the same way it is over in the other problem. So I'm going to write the x minus 1 first. Remember, the commutative rule of multiplication tells you that you can write the terms in any order. So again, we want to double check and make sure that all our denominators are the same, and you can see they are. So now we have a common denominator, and I'm going to move this down a little bit. So because we have a common denominator, we can go ahead and add these fractions. And again, if you're going to make a mistake, it's going to be right here because you're subtracting that fraction, so all those signs are going to change. So we don't have a lot of room here, so I'm just going to go ahead and go on to the last step here. So we have 30 minus 30x minus 30 minus 42x squared minus 35. We don't change any signs so far in the numerator because we're just adding those two fractions, those first two fractions. But here we have to change the signs. It's going to become minus 24x and plus 48. Again, if you're going to make a mistake, that's where it's going to be. Those signs. Okay, I'm going to make that look nice and neat, I'm going to move that to the center. We added all those together. Now we just have to combine like terms. And let me see if I can find some more room. So again, I'm going to try to write in descending order of powers. So negative 42x squared plus 6x. 30x minus 24x is 6x. And negative 30 plus negative 35 is negative 65. Negative 65 plus 48, that's negative 17. And then we just rewrite the denominator. So if you got that one right, that was very good. That one was kind of a doozy. Now let's go over and check and make sure we did all this correctly. Everything looks right. So there you go. On to the next problem. We're going to simplify this expression. This is a multivariate expression here. So I have 49 and 36. Those are perfect squares. So this is probably going to be a difference of two square problems because I'm subtracting. What number times itself is equal to 36? Well, that's going to be 6. And you have a's, so you're going to have to put an a there. Two A's. What number times itself is equal to 49? Well, obviously that's 7. And because there are B's, you're going to have to write your B's. And whenever you use difference two squares, you always put a plus or minus. Or plus and minus. Okay, now the bottom, it looks like it's going to be a quadratic. And what two numbers multiply to 6? I can use 2A. But you know what? Up here we have 6A's. So my instincts are telling me that it's going to be 6A and A, because something's probably going to cancel out. It says to simplify. So that's kind of a hint. Now over here, what two numbers multiply to 14? I'm going to try, again, stuff is going to cancel out. So this is a 6A plus 7B. So I'm going to try the 7B here and B over here. Actually 2B, I'm sorry. And now I'm going to FOIL out this yellow part. We have to FOIL it to make sure it works. F O I L. F O I L. So now add 12AB and 7AB, and do you get 19AB? And the answer is yes. So we did it correctly. So why do we care? Well, we care because now look what's going to happen. The 6A plus 7B is going to cancel out, and this expression is going to get a lot more simple. And we don't have to write the parentheses anymore because the numerator is not being multiplied into anything, and the denominator is not being multiplied into anything either. So we're done. So if you got that one right, good job. Okay, on to number 15. It says rationalize the denominators. So what does that mean, rationalize the denominators? Well, remember, you can't have a root in the denominator, and you can't have really any denominator in a root. You see, these denominators are all in the roots. We can't have that. And so we're going to use this principle. Remember this principle that we went over. The square root of A over B is equal to the square root of A over the square root of B. Remember, we learned that. So for number 15, we have root 2 over root 81, but that's really easy because what number times itself is equal to 81? Well, that's just 9, and you're done. So that one was easy. Now again, you want to try these problems. If you think you can try these, go ahead and rationalize the denominator. Get rid of that root in the denominator. You're going to have to multiply both sides of this fraction by something to get rid of that root in the denominator. If you can do that, go ahead and try 16. If you're not sure how we did these problems before, let me remind you, the only way to get rid of root 13 is multiplying it by itself. The problem is you can't just multiply the denominator of a fraction. If you multiply the denominator, you have to multiply the numerator by the same thing, or else the value of the fraction is going to change. You can't just change the value of a fraction. 3 times root 3, that's just going to be 3 root 3. And now we're going to use another principle that we learned. We learned that the square root of AB is equal to the square root of A times the square root of B. Now, if you flip that equation around, which, you know, you're always allowed to flip an equation around. It's called the symmetric property. We haven't learned that yet, but that's the technical name for it. Now you can see that we can combine these root 3's. Root 3 times root 3 is root 3 times 3. So we end up with 3 root 3, and that ends up being root 9. 3 times 3 is 9. Now, please be aware that you can skip some of these steps. You don't have to do all these steps. I'm just showing you what's happening here. What number times itself is equal to 9? Well, that's just 3. And look what happens. These 3's actually cancel out. So I can just cancel out those 3's, and we end up with root 3. So that was a nice and neat answer there. All right, so I'm going to put some dividers here. So now on to number 17. 17 is going to be a more difficult problem if you think you can try it, or if you know, even if you're not sure that you can do it, it's good to attempt the problem, you know, because it gets you thinking about the problem. So we're going to use that principle up there, the green principle up here at the right. This problem, I should mention, we have two problems here. One problem, like I said, is we have a denominator in the root, but we also have something in the root that has perfect square factors, you see. So we're going to have to take care of both of those problems. So I'm going to use that principle at the upper right to break it up into two roots. Now, you can get rid of the root in the denominator first, then you can take care of the perfect square factor here, but that's going to be more difficult because the numbers are going to be bigger. So first, what I'm going to do is I'm going to take care of the perfect square factor in the denominator. I'm going to factor 27 to 9 times 3. And then I'm going to use this principle over here. And in order to use that principle, I'm going to have to reverse the equation again. So now I reversed it. So it looks like that. And so what that means is I'm going to break up the root into two roots now. And the reason I did that is because now the square root of 9, that's just 3. And I can get rid of that dot. So very important to understand that this root 9, the root 9 changed into this 3 here. So now we got rid of that perfect square factor in 27 inside the root. So that was the first task that we have to do. Now we have to get rid of that root 3 in the denominator. Remember, we're not allowed to have a root in the denominator. So how do we do that? Well, we just did it in this other problem. You see how we multiplied both sides by root 3? Turns out that we have the same number here. So I'm going to go ahead and just multiply both sides by root 3. I made it kind of easy for you because I gave the same exact root to get rid of in the denominator. I didn't do that on purpose. That was just a coincidence. So now, again, using the same principle, I'm not going to reverse this again, but it's just going from right to left. We're multiplying root a times root b to get root ab. So that becomes 10 times 30. And down here we have root 3 times 3. Then you're left with root 30 over 3 times root 9. And you see where we're going with this. Root 9, that's just equal to 9. So we have root 30 over 3 times, did I say root 9 is, what did I say? The square root of 9 is 3, right? I don't know what I said there. So what number times itself is equal to 9? That's 3. And here we go. We're almost done. Root 30 over 9. Now, again, you're probably thinking to yourself, I can't do this. This is a headache. This is ridiculous. This is too much work. Please keep in mind, you don't have to show all these steps. I'm just doing this so you can see what's happening. You can skip a lot of these steps. All right? So don't think that you have to show every single one of these steps. In fact, I don't want you to show every single one of these steps because that's going to take too long. You're not going to be able to finish the exam in a reasonable amount of time. Okay, so we got root 30 over 9. So now on to number 18. We're going to use this green principle up there. So we get root 75 over root 28. But again, we have two problems. We have to pull out perfect squares. So I'm going to pull out 25 times 3. Or I'm going to factor it to 25 times 3. And here we have 4 times 7. And then I'm going to use the principle at the right over there to break these into two roots. Again, this is all just using the same principles over and over and over again. So now root 25, that's equal to 5. And root 4, that's equal to 2. So that root 25 became 5, and the root 4 became 2. So now we need to get rid of that root 7 in the denominator. So I'm going to multiply both sides by root Maybe I shouldn't use purple because we already used purple highlighter. Root 7 times root 7, multiplying root 7 by both sides. So then we end up with 5 root 3 times 7 over 2 times root 7 times root 7 times 7. You know what? I'm going to move this entire problem to the right over here. So now we have some more room, and we end up with 5 root 21 over 2 root 49. And we just have one more step to simplify. Actually, two more steps. So root 49 is 7. So that root 49 turned into 7. And now we just have to write the final answer. So I'm going to move this down a little bit. So we have 5 root 21 over 14. That's the final answer. So if you got that answer, good job. Okay, so now we're going to some even easier problems. So square root of 36, that's pretty easy. Go ahead and try that one. If you said 6, you're right. What number times itself is equal to 36? That's 6. And try B. See if you can attempt B. And when you come back, we'll do it together. If you don't remember how to do that one, you just multiply -8 and -2 to get 16. And we're using the green principle here, but reversed from right to left. And we get root 3 times 6. So you just combine those roots to one root and just multiply whatever's inside. So then we end up with 16 times root 18. Problem is 18 has a perfect square inside it. So we're going to factor that to root 9 times 2. Then we're going to use the principle up here, break those into two roots. So we get 16 times root 9 times root 2. Now why do we do that? Because root 9, that's just going to be 3. So the root 9 changed into 3. I'm going to go over one more here so we have some more room. And our final answer, 16 times 3 is 48. So we end up with 48 root 2. Again, you cannot have a perfect square factor inside a root. So I've got that answer. Good job. On to number 20. Actually, we're still on number 19. We're going to do part C of 19. So here we're going to use that principle. Maybe I should bring it up. Should bring all these principles that we used with us. So you see that fraction principle at the top there. Square root of 49 over 100, that's just equal to the square root of 49 over the square root of 100. What number times itself is equal to 49? That's just 7. What number times itself is equal to 100? That's just 10. So there you go, you're done. So that one was easy. And this next problem we'd like to, simplify by combining these terms, but we can't because you have lemons, you have apples, and you have oranges. You can't combine those. They're different things. So you're going to have to pull out a perfect square from these two to make it look like a lemon. So go ahead and try part D if you can, and when you come back, we'll do it together. So we have 8 root 3. We can't really do anything with that. But root 27 we can factor to 9 times 3, and 12 we can factor to 4 times 3. Then using the principle in green up there, the second principle, we break it up into two roots. Each one we break up into two roots. Notice that the root 3's, they pop out. See, they're all turning into lemons now. So we have 8 root 3 plus 2 times root 9 is equal to 3. And root 4 is equal to 2. So we have 8 root 3, and then 2 times 3 is 6. and we're left with 2 root 3. We can get rid of the dots. So now we have, they're all lemons here. And so 8 plus 6 is 14, and 14 minus 2 is 12. So we have, in fact, maybe I'll do that by steps, just so you can see exactly what's going on. You don't have to do, more steps, but it's always good to show intermediate stuff. So if you got that answer, good job. We couldn't combine those expressions, but when we pulled out perfect squares from the roots, we could combine them. So that's a common type of problem you'll see. All right, now we're going to simplify this complex fraction. When you're trying to simplify complex fractions, remember this symbol, this fraction symbol here, can be interpreted as a division operation. So we write that as a division sign. That's how we simplify complex fractions. Now, why is this a complex fraction? Well, because there's a fraction within another fraction. That's what it means to be a complex fraction. Now, please be aware that you cannot put a negative symbol right next to a division symbol. You have to use parentheses. Now, at this point, a lot of students would just get stuck. But if I write negative 7x squared as negative 7x squared over 1, then hopefully, maybe that will help you to get unstuck. Remember, you can write anything that looks like a whole number. If something doesn't look like a fraction, you can always make it look like a fraction by writing over 1. So now the big question is, how do we divide fractions? Do you remember how to divide fractions? Well, we change to multiplication and we flip the divisor. So again, we've done this, whoops, I forgot to flip it. So 1 over 7x squared. So we've done this millions of times in my arithmetic course and so on and so forth. So now we're multiplying fractions. When you multiply fractions, you just multiply straight across. 9 times 1 is 9. And xy times 7x squared is 7x cubed y. And of course we have our negative there. So that's the final answer. And that's it. So if you got that answer, good job. All right, on to 21. Now we have a really complicated complex fraction. So what do we do here? Well, we're going to combine the numerators, and we're going to combine, or not numerator, plural. We're going to combine the numerator and we're going to combine the denominator. All right, first. So I'm going to write that 2 as a fraction so we can see, again, we can't really add these together unless we consider them to be both fractions. So remember, you can write 2 as 2 over 1. I'm also going to use this opportunity to factor. Remember, whenever you see some expression that can be factored, it's a good bet that you're going to need to do that. So that's the difference of 2 squares. What number multiplied by itself is equal to 16? Well, that's just going to be 4. And remember, when you're using difference of 2 squares, it's always a plus and a minus. And please be sure to make this yellow fraction line long enough, or else things can get really confusing. So we've written this 2 as a fraction. I changed that yellow 2 to this here, and I changed that blue x squared minus 16 to this expression here, and that's going to help us. So now I need to combine the numerator, so I need a common denominator because I'm subtracting these, right? I need a common denominator, so we need to take that 2 over 1 and multiply both sides by x plus 4. Because the other fraction has an x plus 4, but the 2 over 1 doesn't have one. So we have to get a common denominator. And we have to use the same logic in the denominator here. Here we have an x plus 4 and an x minus 4, but in this denominator we don't have an x plus 4. If we're going to combine those, we need to get a common denominator. And so I'm going to multiply both sides of this fraction, and you must put parentheses. I'm going to multiply both sides of this fraction by x minus 4 so we get a common denominator, so we can combine the terms in the denominator. And this other fraction we don't really have to do anything with because it's already got everything that we need in the denominator. That didn't change. Okay, we need to go back and double check everything, and I can already tell that I did something wrong. You see what I did wrong? That should be a plus 4, not a minus 4. See, that's the type of things that you catch when you go back and check. So I'm double checking here, double checking. Everything looks right, so now we can proceed. And we have 3 over x plus 4, and we have to use distribution. 2 times x is 2x, 2 times 4 is 8. We have x plus 4 in the denominator. And distribution, 5 times x is 5x, 5 times 4 is 20. And over here, nothing changes. We didn't change that fraction at all. Okay, so now we can combine the fractions in the top. So let's go ahead and do that. We have a common denominator. See, we have these common denominators down there. We don't really need parentheses in the we don't really need parentheses in this. I'm going to go ahead and take that away. You can write parentheses, it's not wrong, it's just we don't need it. So now, again, if you're going to make a mistake, it's probably going to be right here. You're subtracting that, so it should be 3 minus 2x, not plus 2x, minus 2x, and minus 8. Both of those signs change. So we combined all that into one fraction. And in the bottom, we have purple-like denominators, common denominators, so we can add those, and we get 6x plus 20. I don't know if it would be helpful to keep these here, keep these highlight. It's not really necessary to do that, but okay, so now we're going to simplify. So we have negative 2x minus 5, and again we don't need the parentheses. I don't know why I keep writing parentheses there. All over 6x plus 20 over x minus 4 times x plus 4. And so now the fraction is a lot simpler. We're going to change this this blue division symbol or the division, the fraction symbol that is. We're going to change that into a division symbol. That became this blue here, just like we did in the previous problem. And again, you don't have to show every single one of these steps. I'm just doing this just to show you what's going on here. So now, when you're dividing fractions, remember you change that division symbol to multiplication and you flip the divisor. So notice now we're multiplying fractions, and notice we have an x plus 4 in the top and an x plus 4 in the bottom. And so we can just combine everything else. We have negative 2x minus 5 times x minus 4 all over 6x plus 20, and that's it. That's all we have to do. Now you can take these negatives out if you want to put it in front of the fraction. There's a lot of different ways to write that, but that's probably what you're going to want to stick with. So let's just double check all that, make sure everything looks right. Again, students hate double checking things, but that's just the name of the game when it comes to mathematics. You better not make a mistake, or else it's almost a guarantee you're going to get the wrong answer. Okay, so everything that we've done so far is the first half of the course. But remember, I said that there's going to be graphing and the three forms of linear equations on this test also. So here's where we get into the three forms of linear equations and graphing. It says graph the following equation using the slope and y-intercept. Now the reason that we're going to use the slope and the y-intercept is because this is in slope-intercept form. Remember, y equals mx plus b. So you can see we have the slope and we have the y-intercept. So remember, you first graph the y-intercept where it crosses the y-axis. Then you use your rise over run to find the second point and connect the dots. So try number 22. When you come back, we'll do it together. All right, we're back. So I'm going to draw my graph here. Be sure to label axes. You're going to get points taken off if you don't label your axes. And I want to make this 3 and 3. Your graph doesn't have to be perfect, but it has to be something. Okay, and so we're going to graph the y-intercept. Now again, maybe I should write over here, b is equal to m first of all is equal to 2, and b is equal to -1. That's going to help us. So -1 is the y-intercept, so that means right here at this red little point there, that's -1. That's the y-intercept. That's what that tells us. And now we're going to keep our pen on that point, and we're going to write this slope as 2 over 1. And what that means is we're going to go up to 1, 2, and we're going to go over 1, and bingo, that's your second point. That's how that works, remember? So then that makes your little triangle there, and we can connect the dots. And there you go. So that's our graph. Now, notice up here it says you need to write the points that you use. Label all axes, your intervals, and write the points that you use. So we need to write these points. Now this point here is very easy. That's just 0, -1. That's our y-intercept. But over here we're going to have to do some calculations. We went over 1, so it's obviously 1, and I guess we went up 1, so there you go. So that wasn't too hard to figure out what those coordinates were. So that's it. That's number 22. We used the slope and the y-intercept because we had slope-intercept form. Now we have point-slope form. So how do you think we're going to do this? And by the way, this was method number 3. If you remember, method Roman numeral 3. Remember, we learned 4 methods. So that's number 3 when you use the slope and the y-intercept. Now we're going to use method number 4, which is when you have the point-slope form. So let's draw the graph. And the directions tell us specifically use the point-slope form. So we have to use the point-slope form. We can't just graph it however we want to graph it. You know, choosing 2 random values, x values, and then solving for y, or vice versa, that always works in every graph. But you need to know how to graph it the other ways, because the other ways are actually much faster if you have point-slope form or slope-intercept form. So now, slope-intercept form, if this is kind of switched around, so don't be confused by that, but this is point-slope form. Remember this form? You're used to saying it flipped around like this, but it's the same thing. You remember, by the symmetric property I was mentioning before, that's a fancy name for it. You can flip around an equation whenever you want to. So what that means is that we have the slope. The slope is 2/3, and we have a point. And here's a big thing to understand. It's always going to be opposite signs. So those are both positive 2's, right? we have positive 2, but it changed to -2 and -2. It's very important. A lot of students complain about that. They say, I don't understand why it changes. Well, you don't have to understand why it changes. Just get the problem right. You can worry about why it changes later on. Like I mentioned, if you're going to learn how to drive a car, you don't take the car apart first and try to figure out how every part works. You figure out how to drive the car, and then if you want to become an engineer later on, then you can figure that out. So we have the slope and we have a point. How could I find the slope and a point just by looking at this equation? Well, it's in point-slope form. So obviously you can see a point and the slope. That's the whole point. So let me mark these. Gives some idea of, doesn't have to be perfect, but you want it to make sense. So now, first what we're going to do is we're going to mark our point, -2, -2, which is down here. So that's our point, and we're going to keep our pen on that point. And we're going to go up 2 and over 3. Why up 2 and over 3? Well, because that's the slope, up 2 and over 3. So now we have this point here, and that's going to be 1, 1, 0. And this point over here is going to be, we already have that point, it's -2, -2. You see, that was one of our points there. But please try to be legible when you write all this stuff down. I know sometimes it's hard to fit it in on the graph, but you can just do a line like that. So now we're ready to connect the dots. And again, it doesn't have to be perfect, but just try to make it somewhat straight. So we've labeled our axes, we've written our intervals, and we have our points labeled, and our graph is there, so we're done. So that's number 23. We used method number 4 when you have point-slope form for graphing a linear equation. Okay, 2 more problems here. Now it says graph the following equation by using x and y intercepts. This is method number 2. So when we use x and y intercepts, we have to find 2 points. Sometimes it's called finding a point manually. So for point 1, we choose we can choose our x value or y value. I'm going to choose x. Now, because we're finding the x and y intercepts, we have to let x equal 0. So then we plug in 0 to that equation. When we find the x-intercept, we're going to let y equal 0. So we plug in 0 to the equation, and if you solve that equation, you end up with y is equal to -2. I'm not going to do that because, again, that's just basic, math. So what that tells us is we end up with our point 0, -2. So that's point number 1. Now we're going to find point number 2, which is going to be the x-intercept. So now we have to let y equal 0. Notice that I'm choosing 0 this time. Or in this particular problem, I'm choosing 0 because we have to. It tells us to use the x and y intercepts up here in blue. That's how you find the x and y intercepts. You let x equal 0, solve for y, then you let y equal 0, solve for x. So now we're going to plug into our equation, but now we're going to plug in y because this is a y value. And if you do the math on that, you end up with x is equal to -14 over 3. But what does that mean? Well, to graph it, we need to change that probably into a mixed number. So 3 goes into 14 4 times, and there's a remainder of 2, so that's actually -4 2/3. So what that means is we found the point -4 2/3, 0, which is the x intercept. So this is our x value, and this is our y value down here. Okay, so now that we have those 2 points, we can plot those 2 points. So I'm going to make this 4 up here. And 4 here, -4 here. So -4, 2/3, and 0. So that's going to be about here. And 0, -2, that's going to be about here. So then we just connect the dots. And we need to label and down here we have 0, -2, and there you go. So we have our intervals, our axes are labeled, our points are labeled, our lines drawn, and we're done. So we use the x-intercept in purple, and we use the y-intercept in orange to graph this line. So that's method 2. Now we're going to use, it says use any method for this next problem. And again, if you know what we're doing here, you need to try this on your own. Don't just watch me do these problems. If you think you can take over, and then you can fast forward and see my answer to check. It says use any method, so I'm going to use method number 1, which is basically just choosing some random x value to find one point, and then choose another random x value to find another point. So let's see here. I'm just going to choose x equals 0. So now we plug that into our equation, and we end up with 3y is equal to 1, and y is equal to 1/3. So now the point that we just found is 0, 1/3. We found the y-intercept. Oftentimes it's easy to find the x and y-intercept in these problems. So I'm kind of using method number 2, which is pretty much the same as method number 1. You're just finding 2 points. But the difference between method 2 and 1 is with method 1, you're just finding kind of any points. You don't have to find the y-intercept or the x-intercept. So just to show you that I'm not using method 2, I'm just using any 2 points. I'm going to choose I'm going to choose x equals 1, because I can see that's going to produce an easy number. So now we're going to take our equation up there and plug in 1 for x, and we get 3y is equal to -4 plus 1. 3y is equal to -3. And you can see why I chose that point, or that number. We have y is equal to -1, which makes things really easy. So now our point is 1, -1. So I got that 1 from there, and -1 I got from there, and 0 I got from here. Whoops, gotta use a different color. 0 I put in there, and the 1/3 came from here. So now we're ready to graph this. Just going to use these blue lines to help me space this out. So 1, -1, that's going to be about here, and 0, 1/3 is going to be about here. And we connect the dots. So I have the y-intercept, but the other point was not the y-intercept, so that's why I consider this to be method 1. You're not choosing necessarily the x and the y-intercept. Method 2, you must choose both the x and the y-intercept for your points. So now let's label these points. We have 0, 1/3, and for this point we have 1 and -1, and that's it. Our graph is labeled, the axes are labeled, intervals, and the points, and the graph is drawn. All right, so if you got that answer, good job. That was the class today. Sorry that class went a little long, but studying tends to intensify as you're preparing for an exam. If you want to take a picture of all the work that we did, here's screenshot number 1. This will help you do your practice test for homework. Screenshot number 2. And screenshot number 3. Screenshot number 4. And number, maybe I should zoom out there, number 5. Number 6. And don't go before you get your practice test for homework. So get a screenshot of this page here. And screenshot number 2. This is your practice test for homework. Screenshot number 3. And number 4. And number 5. And number 6. And don't forget to get the answers. Remember, it's not enough just to attempt the problems. You must get the correct answer, or else you're just wasting your time. So that's the first screenshot there for the answers. And here's a screenshot for the rest of the answers. Do not go on to the next class. Do not take my actual test in this class unless you've done this practice test. You cannot pass a math exam without doing some studying, and this practice exam forces you to do some studying. So do the whole thing completely, correctly, and neatly, and keep all your work in order in your binder. And I'll see you in the next class.